Our solar system is a busy place. Planets whirl around the sun, moons twirl around planets. Mars, our red neighbor, has two such dance partners, Phobos and Deimos. Today we're focusing on the smaller, more distant moon Deimos. Don't let its size fool you. This little moon holds big clues about our solar system's past. Deimos might look like a mere potato in space, but it's a potato with a story to tell. A story of cosmic collisions, planetary formation, and maybe even the potential for future exploration. It's a story that connects us to Mars and the broader mysteries of the universe. Deimos waits patiently in its orbit, a silent observer to the history of Mars. Every crater on its surface, every grain of its dust, whispers tales of ancient events. By studying Deimos, we're not just looking at a moon, we're opening a window to the past. Deimos is small, even for a moon. It's dwarfed by our own moon, and even its sibling Phobos is bigger. Imagine a rock only about 15 kilometers across. That's Deimos. You could practically walk across it in a day if you could handle the low gravity and lack of air. But don't underestimate it. What Deimos lacks in size, it makes up for in intrigue. Its small size means it's probably a captured asteroid. This means it wasn't formed around Mars like our moon. Instead, it wandered too close and got trapped by Mars' gravity. This makes Deimos a time capsule from the early solar system. Imagine the stories Deimos could tell if it could talk. It might have witnessed the birth of planets, the chaos of the early solar system, and the slow, steady evolution of Mars. Even though it's small and seemingly insignificant, Deimos holds a treasure trove of information. Why should we care about this tiny, distant moon? Because Deimos isn't just a celestial object. It's a stepping stone. Imagine a future where humans venture to Mars. Deimos, with its stable orbit and low gravity, could be the perfect base camp. Astronauts could control robots on the Martian surface without the delays of communicating all the way from Earth. Studying Deimos could teach us how to use resources in space. It could help us understand the challenges and possibilities of living on other worlds. Deimos, in a way, is a key to unlocking our future in space. So the next time you look up at the night sky, remember Deimos. It might be small and far away, but it holds big dreams for the future of humanity. It's a reminder that even the smallest objects in the universe can have a profound impact on our understanding of space and our place within it. For centuries, astronomers gazed at the stars, charting planets and their majestic dance across the cosmos. They observed Jupiter's swirling storms, Saturn's magnificent rings, but Mars, the red planet, held a quiet mystery. Did this celestial neighbor, so similar to Earth in some ways, also have companions? Did moons grace its skies? The idea wasn't new. Johannes Kepler himself, the astronomer who deciphered the laws of planetary motion, speculated that Mars might have two moons. His reasoning was more philosophical than scientific, based on a sense of celestial harmony. Two moons for Mars, echoing the two prominent celestial bodies known at the time, the Sun and the Moon. Kepler's idea, though lacking observational evidence, took root in the scientific imagination. It sparked a centuries-long quest, a celestial treasure hunt. Astronomers, armed with ever-improving telescopes, scanned the Martian skies, hoping to be the first to spot these elusive companions. In this pursuit of Martian moons, one name stands out: Asaph Hall. An American astronomer at the United States Naval Observatory, Hall was a meticulous observer of the cosmos. In 1877, armed with the observatory's powerful new telescope, the largest refracting telescope in the world at that time, Hall set his sights on Mars. The telescope, with its massive 26-inch lens, was a marvel of engineering. It gathered light from the faintest stars, bringing them into sharper focus than ever before. This was Hall's weapon of choice, his tool for peering into the cosmic depths and unlocking the secrets held by Mars. Night after night, Hall patiently observed Mars, meticulously charting its position and searching for any telltale signs of orbiting companions. The work was tedious, requiring unwavering focus and a tolerance for the quiet solitude of the observatory. But Hall pressed on, driven by the thrill of discovery and the allure of the unknown. Hall's task was far from easy. Deimos, the smaller and fainter of Mars's two moons, was notoriously difficult to spot. Imagine a tiny pebble orbiting a brightly lit basketball. That was the challenge facing Hall. Deimos was lost in the glare of Mars, a faint whisper against a brilliant backdrop. Adding to the difficulty was Deimos's speed. This tiny moon zipped around Mars at a surprising pace, completing an orbit in just over 30 hours. This meant that any potential sighting would be fleeting, a brief flicker against the background stars. Hall, however, was not easily deterred. He employed a clever strategy, using a technique called occultation. He deliberately positioned his telescope so that Mars itself would be blocked from view. This minimized the glare and allowed him to focus on the area immediately surrounding the planet. The night of August 12, 1877, dawned clear and crisp over Washington, D.C. The air was still, ideal for observing. Asaph Hall, stationed at his usual post at the Naval Observatory, resumed his nightly vigil of Mars. He had been at this for weeks, meticulously scanning the Martian neighborhood, his patience tested time and again. Then, in a moment that would forever etch his name in the annals of astronomy, Hall spotted it. A faint speck of light, a celestial firefly, danced near the edge of where Mars should be. It was incredibly faint, easily missed, but unmistakably there. He had found it, a Martian moon. Hall continued his observations over the next few nights, confirming the object's presence and meticulously charting its movement. It was indeed a moon, a tiny companion eternally bound to the red planet. He named it Deimos, after the Greek god of terror and dread, an apt name for a celestial object that had eluded astronomers for so long. A celestial potato, the curious shape of Deimos. Imagine a potato in space. Now picture it covered in craters and dust, tumbling end over end. That's Deimos, Mars's smaller moon. Its shape is far from a perfect sphere. It's lumpy and irregular, more like a giant space rock than a neatly formed moon. This peculiar shape tells a story, a tale of cosmic collisions and chaotic beginnings. Unlike our own moon, which likely formed from a massive impact early in the solar system's history, Deimos bears the scars of countless smaller collisions. Each crater, each dent, is a testament to the rough-and-tumble environment of the early solar system, a time when asteroids and comets roamed the cosmos with reckless abandon. This battered appearance gives Deimos a certain rugged charm, a sense of ancient history etched onto its very surface. It's a reminder that space is not a gentle place, but a dynamic arena where objects collide, break apart, and reform over eons. Walking on a sponge, gravity and composition. If you could somehow stand on Deimos, and let's be clear, this is purely hypothetical given the lack of atmosphere and the challenges of getting there, you'd feel remarkably light. Deimos's gravity is incredibly weak, a mere fraction of what we experience on Earth. A 100-pound person would weigh a mere 2 ounces on Deimos. This weak gravity is a result of Deimos's small size and low density. Scientists believe that Deimos is largely composed of porous carbonaceous materials, similar to some types of asteroids. Imagine a giant space sponge riddled with holes and gaps. That's a simplified picture of Deimos's interior. This composition and low density provide crucial clues about Deimos's origins. They suggest that it's likely a captured asteroid, a wanderer from the asteroid belt that strayed too close to Mars and got ensnared by its gravity billions of years ago. A cratered history surface features and their tales. Deimos's surface is a time capsule, a record of billions of years of cosmic bombardment. Unlike our moon, which has experienced volcanic activity and other geological processes that have reshaped its surface, Deimos is a relatively pristine relic of the early solar system. The most prominent features on Deimos are its craters, depressions formed by impacts from asteroids and meteoroids. These craters range in size from small, pockmark-like features to larger depressions that dominate the landscape. Two of the largest craters, Swift and Voltaire, are named after prominent literary figures who wrote about the possibility of Martian moons. These craters tell a story of constant bombardment, a testament to the chaotic early days of the solar system. By studying the size, distribution, and age of these craters, scientists can glean insights into the history of impacts in the Martian system and the types of objects that have collided with Deimos over time. Section 4. Swift and Steady. Deimos's orbit around Mars. Deimos circles Mars in a remarkably circular and stable orbit. Unlike some moons, which have eccentric or tilted orbits, Deimos follows a predictable path, completing one orbit around Mars in just over 30 hours. This means that Deimos races across the Martian sky much faster than Mars rotates, resulting in a curious phenomenon. If you were standing on Mars, you would see Deimos rise in the east and set in the west, just like our moon. However, it would complete this cycle multiple times in a single Martian day. The sight of Deimos zipping across the sky, a faint point of light against the backdrop of stars, would be a constant reminder of the celestial dance playing out above. This stable and predictable orbit makes Deimos a potentially attractive target for future space missions. Its low gravity and close proximity to Mars make it a prime candidate for a space station or a base camp for robotic exploration of the Martian surface. Section 1. Deimos beckons, a stepping stone to Mars. Imagine this, humans on Mars. Not just robotic rovers but actual boots on the red planet. It's a dream that has captivated scientists, science fiction writers, and space enthusiasts for generations. And Deimos, that little potato moon, might just be the key to making it a reality. Think of Deimos as a stepping stone, a cosmic gas station on the way to a more distant destination. Its weak gravity means that landing and launching spacecraft would be relatively easy, requiring less fuel and energy than traveling directly to and from Mars's surface. This makes Deimos a strategically important location for future missions. From a base on Deimos, astronauts could remotely control robots on Mars, exploring its canyons, volcanoes, and ancient riverbeds without the delays inherent in communicating with Earth. Deimos could even serve as a staging ground for constructing and launching missions deeper into the solar system, leveraging its resources and strategic location. Section 2. Cosmic Laboratory, Unlocking Secrets of the Solar System. Deimos isn't just a stepping stone, it's a treasure chest of scientific knowledge waiting to be unlocked. Its ancient surface, relatively untouched by geological processes, holds clues about the early solar system, the formation of planets, and the bombardment history of the inner solar system. By studying the composition of Deimos's rocks and soil, scientists can learn about the materials that were present in the early solar system, providing insights into the building blocks of planets. The craters on its surface can reveal the size and frequency of impacts over billions of years, offering a glimpse into the chaotic early days of our cosmic neighborhood. Furthermore, Deimos's weak gravity makes it an ideal place to study the effects of long-duration spaceflight on the human body. Understanding how humans adapt to low-gravity environments is crucial for planning future missions to Mars and beyond. Section 3. The Martian Connection. Deimos as a witness to history. Deimos, in its silent orbit around Mars, has witnessed eons of Martian history. It has seen the rise and fall of volcanoes, the ebb and flow of ancient rivers, and perhaps even the fleeting presence of liquid water on the Martian surface. This makes Deimos a valuable resource for understanding the evolution of Mars. Scientists believe that Deimos and its larger sibling Phobos may be composed of material blasted off the Martian surface by giant impacts early in the planet's history. If so, studying these moons could provide insights into the composition of the Martian crust and mantle, regions that are difficult to study directly. Deimos's unique perspective, orbiting above the Martian equator, also offers opportunities to study the planet's global weather patterns, magnetic field, and interactions with the solar wind, the stream of charged particles constantly flowing from the Sun. The dream of humans on Mars is closer than ever before. With advances in spacecraft technology, life support systems, and our understanding of the challenges of space travel, a human mission to Mars is no longer science fiction, but a tangible goal within reach. And Deimos, that small, unassuming moon, could play a pivotal role in this grand endeavor. Imagine a future where Deimos is home to a thriving scientific outpost, a hub of activity buzzing with researchers, astronauts, and robotic explorers. From this vantage point, humans could unlock the secrets of Mars, unravel the mysteries of the solar system, and perhaps even pave the way for the long-term human exploration and settlement of our celestial neighbor. The journey to Mars is fraught with challenges, but the potential rewards are immeasurable. And Deimos, that little potato moon, might just be the stepping stone that helps us reach for the stars. Deimos, the smaller of Mars's two moons, may seem like an insignificant speck in the vastness of space, a mere celestial potato, dwarfed by its larger sibling, Phobos, and our own moon. But appearances can be deceiving. This little moon, with its cratered surface and peculiar shape, holds within it a story spanning billions of years. It whispers tales of the early solar system, of cosmic collisions, and the formation of planets. Deimos is more than just a relic of the past. It's a window into the processes that shaped our cosmic neighborhood, a time capsule preserving clues about the early solar system that have long since vanished from Earth. But it's also a beacon, a stepping stone to the future of human exploration. Its low gravity and stable orbit make it an ideal location for a Martian base, a hub for scientific research, and a launching point for missions deeper into the solar system. Imagine a future where humans walk on Mars, conducting research, building habitats, and perhaps even establishing a permanent presence. Deimos, with its strategic location and resources, could be instrumental in making this vision a reality. The human spirit is driven by a fundamental curiosity, an insatiable desire to explore the unknown, to venture beyond the familiar, and to push the boundaries of knowledge. It's what led our ancestors to cross oceans, to scale mountains, and to explore the farthest reaches of our planet. And it's what compels us to reach for the stars. The exploration of space is not merely about scientific discovery, though that is a significant part of it. It's about challenging ourselves, about pushing the limits of our technology and our understanding of the universe. It's about inspiring future generations to dream big, to set their sights on goals that seem impossible, and to never stop questioning, exploring, and reaching for the unknown. When we explore space, we learn not only about the cosmos, but also about ourselves. We gain a new perspective on our place in the universe, a sense of humility in the face of its vastness, and a deeper appreciation for the fragility and preciousness of our own planet. Our exploration of Deimos is just one small step in the grand adventure of human exploration. It's a journey that has no end, a continuous quest for knowledge, understanding, and perhaps even the discovery of life beyond Earth. As we continue to explore our solar system and beyond, we will undoubtedly encounter new challenges, new wonders, and new mysteries to unravel. But one thing is certain: the spirit of exploration, the drive to push the boundaries of human knowledge and experience, will continue to propel us forward. Just as Asaph, with his patient observations, revealed the secrets of Deimos over a century ago, future generations of explorers will continue to unveil the mysteries of the cosmos, revealing new truths about our universe and our place within it. So, let us continue to explore, to learn, and to dream. The universe, with all its wonders and mysteries, awaits. And Deimos, that little potato moon, will be there, a silent witness to our journey of discovery.